So, in the world of industrial automation, there's this huge debate brewing. Do you stick with what's worked for decades, or do you embrace a totally new approach? Today, we're diving into one of the most misunderstood topics in the field, the IEC 61499 standard. The big question is it just another programming language, or is it a completely different way of thinking about how our machines talk to each other?
So here's what we're going to do. First, we'll set the stage with a central debate. Then, we'll unpack what IEC 61499 actually is. After that, we'll get into why this is all blowing up right now. We're also going to hear from some experts on the front lines, and then we'll wrap it all up with the one idea that really ties it all together: syntax versus semantics.
All right, let's just get right into it. The whole argument really boils down to one simple question. I mean, we've got standards that have powered factories for decades. They work, right? They're super reliable. So why on earth would we want to rock the boat now? And this comment from Davey DeMeyer pretty much sums up what a lot of engineers are thinking. The current standard, IEC 61131, it's powerful, it's familiar, and hey, it gets the job done. You know the saying, if it ain't broke, why fix it? What is all the fuss about? Well, the fuss really kicked off with this super thought-provoking LinkedIn post from Franco Antonio Cavadini. He basically tackled that if it ain't broke mindset head-on, and his analysis, plus the huge debate that it sparked, is exactly what we need to get to the bottom of this whole thing.
Okay, so to really get a handle on this debate, we have to clear up the single biggest misconception about IEC 61499. We really need to understand what it actually is, and just as important, what it isn't. And this right here gets to the heart of it. The big misunderstanding is that people think IEC 61499 is some new programming language that's supposed to replace the ones engineers already know and love. It's not at all. Think of it more like a higher-level framework, a set of rules for how different software components written in any language can talk to each other and work together. So how does it actually pull that off? Well, Cavadini breaks it down into a few core ideas. It's built for a world where things happen unpredictably. It standardizes the model of how things get calculated. And here's the kicker. It separates the what, the actual logic, from the where, the hardware it runs on. And that separation is what creates so much incredible flexibility. And this is the key takeaway, for sure. Cavaldini calls it a shared conceptual foundation. See, it's not about arguing over the specific grammar or the syntax you use to write a line of code. It's about everyone agreeing on what things mean and how they're supposed to behave. It's a language of meaning, not just words. Okay, so that's all great in theory, right? But why does any of this matter right now? Why is this debate suddenly so heated? Well, the answer is all around us. It's in the massive changes that are sweeping through the entire industrial world. Just try to picture a modern factory. It's not just a few isolated machines on a line anymore. We're talking about the industrial Internet of Things, with countless smart sensors at the edge, digital twins that are simulating the entire process, and everything is constantly talking to the cloud. The level of complexity is just exploding. And here's the goal of all this. To manage that explosion of complexity, you need what Cavadini calls a homogeneous semantic framework, or, in plain English. You need a single, shared rulebook for how everything behaves, a way to orchestrate all these different pieces, from a tiny sensor on the factory floor to a service in the cloud, so they act as one big, cohesive system. But hey, this isn't just one person's theory. The real power here is in the community of experts who jumped into the discussion. So let's hear what they had to say. Timo den Hartog made this fantastic point with an analogy. He said, a century ago, horse owners didn't ask for a car, they just asked for a faster horse. It's just a perfect way to describe a paradigm shift, isn't it? It's really tough to see the benefits of a whole new system when you're just focused on making tiny improvements to the one you already have. Then you have Greg Bruchhout, who brings up a huge real-world problem, the talent shortage. He points out that when every hardware company has its own special dialect, training new engineers becomes a total nightmare. A common framework that isn't tied to specific hardware could make it so much easier to find and train people. Stephen Maltby, who's a system integrator, he chimed in with his perspective. And for him, it's all about flexibility. Instead of being stuck with this bloated, one-size-fits-all software, a standard like this lets him build lean, custom systems that do exactly what the customer needs and absolutely nothing more. And Jean-Baptiste Fontaine really brings it all home. This isn't just about code or hardware. It's about collaboration. A shared standard,
A common language of meaning is what lets an entire industry work together to innovate and move forward, way faster.
So after all that, what's the one thing you really need to remember from all this? Well, it all boils down to one simple but really powerful distinction: syntax versus semantics.
This slide just says it all. The old standard, 61131, is about syntax. Think of it like the grammar and spelling rules of a language. But the new standard, 61499, is all about semantics. That's the actual meaning of the story you're telling. See, they aren't competitors. One is about writing correct sentences, the other is about making sure the whole book actually makes sense.
And that leaves us with this one last question to chew on. As our industrial world gets more and more complex, maybe the next big leap forward isn't a new way to write code, but a new way for all of us to agree on what that code actually means. Is a shared language of meaning the real key to unlocking the future? I guess that's what this whole debate is really about.